that's absolutely a valid question, because we know that humans and chimpanzees can be infected by the same retroviruses. That's how we got HIV. But again, they're forgetting the diversity of retroviruses and the randomness of where they insert in genome. Just recently, we found a very unlikely retrovirus in lemurs, a whole different species of lemurs. And so scientists thought, well, maybe this retrovirus inserted in a common ancestor of lemurs like 85 million years ago. And that didn't seem quite right to them, but it's a possibility. And they also thought it was a possibility that this retrovirus is independently inserted in several species of lemur. So they didn't just guess or throw up their arms and say, whatever, it's the older one. They looked at those sequences and determined that they were actually very different retroviruses, and that these were two independent events. So we know when things are random, and whether it's common descent that is the more likely explanation, or independent insertion sites.
Just this past week, I think this is probably the one that we were just referring to, the two different lemur species in Madagascar that were found to have the same, and it's very clear, the two different species of lemurs in Madagascar suffered independently and just about the same time multiple germline infections. It says here that the whole thing was older than previously inferred by the DNA differences between between what they see from the past in these now existing lemurs and what they see in living viruses. And it happened independently. Two separate lineages got this endogenous retrovirus. Well, viruses can infect different species. It happens all the time. The report here in Public Library of Science Genetics just of this week says the viruses that were endogenized or got into the genome in the two lemur species were nearly identical. Yet, of course, these might have been 38 million years ago, but today the sequences are nearly identical, showing that they are probably the same thing. Two different species of lemurs got the same cold or whatever it was. You know, isn't it possible that people and lemurs, or people and chimpanzees, could get the same virus at the same time, and then those same endogenous retrovirus sequences can run into the genome, and it can, yes, indeed, make it look like, if your paradigm is that chimps and humans have the same grandfather, it would look like that would be in support of that. Or it could happen, it could fit right in with the creation paradigm too. They both just simply contracted the same virus, which then implanted the retrovirus sequence into the genome. Again, this is transparent to the issue. How many of these things are actually at the same location on the same chromosomes? How many of them are, in other words, orthologous? They really are, or homologous. And how similar are they? I think this probably needs more research. I think you will see evidence that goes both ways easily in molecular genetics. I think you will see evidence that goes one way or the other. Personally, I think you'll see more evidence going the creation paradigm way, but evidence is not proof. It's stuff that helps you think that your opinion is stronger, but proof is what's needed in science. Data, logic, reason, and thinking. That's what we need. It's okay to have theories. It's okay to make assumptions. Those things are not wrong, but we should not teach them as though they're facts. But we should not teach them as though they're facts.
and that retroviruses are highly specific in the area of the genome they insert into. It is inevitable that at least 20, 40, 60, maybe 100 endogenous retroviruses will be found at exactly the same place in humans and chimps from separate infections. Hence, human endogenous retroviruses prove absolutely nothing about common ancestry.